and we're here at the IDTechX show. Hi.
Hello.
So who are you?
Hi, I'm Su-Ming Zhu. I'm the CEO of Ampcera.
What are you doing here?
Okay, so this is a sample of composite flexible solid state electrolyte materials that can be used in the next generation solid state batteries.
So you can make battery out of this.
Yes.
There's a lot of talk of solid state batteries, right? What's special about solid state batteries?
Okay, yeah, solid state batteries, as we highlighted here, it can deliver double the energy density, and it has intrinsic safety features. It doesn't catch fires in EVs or consumer electronics, and with our advanced manufacturing technology, we can do flexible batteries, we can do low-cost manufacturing, so it actually helps to reduce the manufacturing cost by 50%, while at the same time improve the energy density by 100%.
So what does it mean? Double the battery?
Yeah, so that means the electric vehicle, like Tesla cars, can drive double the range.
Double the range?
And lower the cost.
Lower the cost?
Yes.
Smaller size?
Absolutely.
How soon?
Well, so we're looking at the, right now, it's at very intensive R&D worldwide, and we are one of the major suppliers of these kind of solid electrolyte materials. We're looking at the next about 5 years, we'll see the commercial product based on solid state batteries on the road. Actually, there's some news that Toyota will be the first company to showcase their solid state battery EVs at the Tokyo Olympics. That's in next year, right?
So a lot of people working on it. What is this one? Is it different?
Yeah, so we have developed different recipes. This one have a lower thickness, so it's a thinner. So it's a thinner solid electrolyte membrane. So it's made by the roll-to-roll manufacturing process, as we demonstrated here from the schematics. Here's a picture from our lab. It's not fully automated yet, but it shows the concept and the way we would integrate the solid electrolyte membrane into a battery would be an automated roll-to-roll manufacturing process. So we're very excited about this new technology.
So you mentioned Toshiba?
Toyota.
Toyota, sorry.
Yeah.
So who's making the cutting edge, most advanced solid state today?
Well, Toyota is definitely the worldwide leader in solid state batteries.
Toyota? Who else?
Yeah. Well, so we know all the major automotive OEMs are working on it. So companies like Volkswagen, BMW, and others. And in the US, the GM and Ford. These are all the companies we have more or less collaborations with.
So the solid state battery is not lithium ion? Or can it use lithium ion?
Yeah, it is actually still lithium ion.
But it's a different way of making it?
Yeah, exactly. It doesn't use the liquid. Traditional lithium-ion batteries use liquid electrolyte. So that would allow lithium ions to travel in the liquid media. With solid state, the lithium ions would travel through the solid electrolyte. The membrane is like this.
Yeah, it just depends on.
5 years. Why not sooner? How does it get sooner? Are you a startup or?
Yeah, we're a startup company.
So if you get some huge customer or investment, things can go much faster?
Absolutely. Yeah, so that will help us as a major solid electrolyte materials developer to accelerate the materials development and also accelerate the manufacturing process development.
So where are you based?
We have an office here in Silicon Valley, and we have R&D lab based in Arizona, where it's very dry, so it helps us with the materials production there.
Dry is good?
Yeah, dry air, because some of the solid electrolyte materials actually don't like moisture. And in general, battery manufacturing doesn't like a lot of moisture in the air. Arizona is dry. Just by nature, it helps.
Is this one of the challenges to be fine when it's wet, in wet conditions, or what's the main challenge in the next 5 years or sooner to get solid state be big?
Yeah.
What's the biggest challenge?
Yeah, right now we're seeing, because the solid state different from the liquid-based battery systems, it uses new materials, like solid electrolyte materials we're producing. It also requires some new manufacturing processes to integrate these new materials into the new battery designs. So there are like interface challenges, manufacturability challenges, and that's why we focus on the most critical part, which is the materials itself and the manufacturing of the materials. So we can accelerate this commercialization process.
And 10 times faster charging, really?
Yep, so that's based on a patent pending technology we have filed with the US Patent Office. We have developed a proprietary technology that would allow the lithium ions to transfer more than 10 times faster. So that would allow the battery cell to be charged and discharged 10 times faster.
And when you say battery cost less than $100 per kilowatt hour, what is it now, a battery cost currently?
Now it's more or less anywhere between $150 and $200 per kilowatt hours.
So you're talking half price, kind of?
Yeah. Yeah,
All right.
and that's the goal set by the US Department of Energy to be achieved in the next 5 or 10 years.
How can you be a drop-in to the existing infrastructure?
Yeah, great question. Yeah, so we call it drop-in because we have developed this row-to-row manufacturing process. So now our technology would allow us to use the new solid electrolyte materials and fit into the existing production line without changing a lot of the manufacturing facilities. So that's why we call it a drop-in.
Is this how it looks in the manufacturing? Is this the stuff that will be happening?
Yeah, so that just shows the concept, and that's the picture from our lab. This is like a picture to show how it would be used in the manufacturing floor.
How's this IDTech X show for you?
Oh, this is a great event. It's a show to bring together a lot of technology companies, and a lot of visitors to the show floor are companies that we would want to work with, either customers or collaborators, or some are even investors coming from Silicon Valley.